When Oppenheimer made his famous "destroyer of the worlds" remark, he responded later, "Some people confess guilt to claim credit for the sin." This response to the head scientist of the Manhattan Project may sound a little bit bold. However, on the other hand, you might find the scientist behind this remark entitled to it once you get to know him. Many scientists who were involved in the Manhattan Project appeared in the movie Oppenheimer, but the movie could not cover all of them. Probably the most prominent scientist missing in the movie Oppenheimer was the genius mathematician about whom Hans Bethe, Nobel laureate in physics, said his brain indicated a new species, an evolution beyond man. The father of information theory, Claude Shannon, said about him, "The smartest person I've ever met." The Hungarian-American mathematician was one of the few polymaths and most productive scientists of the 20th century, with numerous fundamental contributions spanning various domains of mathematics and science, including physics, computer science, and economics. He stood as one of the pioneers of computer science, a co-inventor of the Monte-Carlo-Method, and developed the theory of self-replication prior to the discovery of DNA. His name was Johnvonneumann. Neumann was born in 1903 in Budapest. He wrote his PhD thesis on axiomatic set theory and received his doctorate in mathematics from Pázmány Péter University in Budapest in 1926. He went to Göttingen to study mathematics under the most influential mathematician of that time, David Hilbert, and eventually secured a position as a lecturer at the University of Berlin. In 1929, he accepted an invitation from Princeton University as a visiting lecturer in mathematical physics, a field which he influenced significantly. His major contributions in mathematical physics, as summarized by his friend and Nobel laureate Wigner, included unbounded operators, group representations in Hilbert space, and the theory of ergodic systems. He was affiliated with the School of Axiomatic Field Theory and advocated for a rigorous mathematical approach in quantum mechanics. In 1932, he published his renowned book, Mathematical Foundations of Quantum Mechanics, in which he elucidated the statistical interpretation of quantum mechanics. As a mathematician involved in the Manhattan Project, he focused on the mathematical design and modeling of explosive lenses, a mechanism for creating a more efficient implosion-type nuclear weapon. This design was employed in historical events such as the Trinity test, the first ever nuclear test, and in the deployment of Fat Man, which was dropped on Nagasaki. Additionally, he calculated the optimal detonation height for nuclear weapons, aiming to enhance their impact by optimizing shockwave propagation. Like Teller, and in contrast to Oppenheimer, he was one of the scientists who continued their involvement in nuclear weapon technologies even after the nuclear attacks on Japan. Differing from Teller, he provided testimony in support of Oppenheimer during his security hearing. While his primary focus and the majority of his publications were centered around applied mathematics and mathematical physics, his scientific contributions were not confined to these domains. His philosophy revolved around the utilizing mathematics in new fields of science rather than solely drawing inspiration from natural sciences, as had been the case before. He also delved into game theory and, alongside Morgenstern, authored the book Theory of Games and Economic Behavior. Morgenstern noted about him, he as a mathematician could so quickly and easily penetrate into the problems of economics and sociology, which I presented to him. Upon joining the Manhattan Project, he developed a keen interest in computer science and scientific computing. His research and pioneer work on the theory of self-replicating computer programs laid the groundwork for computer virology. Collaborating with Ulam, he co-developed the so-called Monte-Carlo-Method, initially applied to neutron diffusion problems in nuclear weapons. However, this method later found extensive applications across various scientific and technological disciplines. Neumann introduced the concept of technological singularity, marking him as a visionary. This concept envisions a future point at which technological advancement suppresses human capacity to keep pace, potentially spiraling into uncontrollable and possibly irreversible change with unforeseeable impacts on human society and civilization. Although he died in 1957 due to cancer when he was just 53 years old, he left a great legacy behind and is considered to be among the greatest and most influential mathematicians and scientists of the 20th century.